Welcome to our first virtual BIMbc in Vancouver. Thank you for joining us. I wanted to go over some of the results of our survey that we sent out. I thank everybody who responded. As you can see, we got quite an array of responses, so thank you. And it's also good to see that quite a few people have come to our events in the past. We put out a question about when we should have our meetings, and it looks like we have exactly half want to go lunch and after work. So our next meeting will be at lunch to see how that works for everybody as well. The meeting duration is highly recommended to go 45 minutes, so we're going to work hard to make sure we can do that. But as you can see, 60 minutes will also work, so we're going to see what we can do to help everybody out. We got some good ideas on trying to get a little more networking going on but in our group. So we're looking into that to figure out how we can do that virtually. We also have got some great ideas on topics. And again, if anybody has any ideas or would like to present, please contact us. Our next BIMbc, which will be on the 22nd at noon, is open source, open data, and the role in the built environment. So I'm kind of excited about to see that. So join us. The meetup invite will be coming out soon. So let's get started and see what Ara's got to say to us about the infrastructure workflows. Take it away, Ara.
So I'm the product manager, product lead at Autodesk for the bridge design software workflows. I am based in Vancouver in Canada, and I do get to work with a lot of our clients on a regular basis. So for those who haven't kind of kept up with the latest on the Autodesk front, my goal today is to kind of illustrate what is that we've been focusing on. So in the last few years, we've been looking at how can we allow our clients to tackle bridge design, specifically or more generally civil structures, from early design, concept, preliminary design, all the way to detailed design. And that's what we have been focusing on. In the most recent releases that came out in April this year, they showcase our focus on how our teams, our clients can work and collaborate on large-scale projects together, how road design and rail design and bridge design and the technical documentation can all work together, collaborate, iterate, evolve a project, etc. So that's my goal today, is to walk through these workflows with 3 kind of workflow videos that I have. So we'll get going. Just before I jump in, I'm going to try to focus the presentation on what's available in the software today if you were to install it. But next month in August, we're coming up with a point release that exposes some key functionalities. I'll also be going over that functionality in this presentation. Again, kind of in summary, what is the big objective of the workflow? It's to allow civil engineers and bridge engineers and the BIM technicians to all work together. So I think, if you have questions, feel free to ask them, and we'll try to manage our time as we go along. So I'm just going to jump in and look at this workflow in general. Okay, and then the second video is kind of to look at the same workflow on a slightly larger scale. And the third video is to walk through what's coming up in the August release next month, which is a particular interest on the bridge engineers side that we see in the middle here. Laura, before I jump in, is my audio coming out clearly enough?
Yep, you sound great.
Okay, so let me go in here. And just confirming that you see a video screen that says the civil structure workflow. Is that what you're saying?
No. You have to do share your whole desktop instead of just the application.
Okay, yeah, I just had to double check. So let me go back to share. I don't usually. Okay, now we should see it, hopefully.
Yes.
Perfect. Were you seeing my PowerPoint before?
Yes.
Okay, so all right, so it was just a question of sharing the screen more generally. So again, here's an example for those in the Vancouver area. You'll probably recognize this location. It's the Kicking Horse Bridge in the Canadian Rockies. I just used it as an example of a semi-realistic bridge to showcase the workflow. So here, imagine you're working on this project and the road design team is using Civil 3D and creating, in this case, a horizontal vertical alignment and really a corridor for this project. And now the second team gets involved, which would be the bridge design team. And in InfoWorks, you can create a site model pretty quickly using Model Builder or ArcGIS data. So you can bring in terrain, topography, aerial imagery. You can bring in point clouds, other GIS information to provide as much context as possible for the development of the bridge design from early design towards detailed design. So in this case, we created a starting model, and while we could also use InfoWorks to model some of the road geometry, in many cases, especially if the intent is to go to detailed design, our clients will be using Civil 3D. And we've been really working on making that integration between InfoWorks and Civil 3D much stronger. So in this case, the bridge design team is going to basically bring in the Civil 3D drawing that is going to serve as the basis for the bridge alignment. So we can go in and bring a data source. So InfoWorks allows quite a number of different data sources to come in, raster imagery and point clouds, etc. Now I'm bringing in the Civil 3D drawing that we saw a moment ago. And because we already have the terrain in this model, I'm just going to bring in the road design model from that drawing. And when you bring it in, you can configure it. Now, what's new as of this April is in the past, we could bring in the alignment, vertical, horizontal. Now we can also bring in the full corridor. So if you have a complex corridor, a detailed custom super elevation, whatever the case may be, you can bring the corridor in. Now, when you bring it in, you can decide whether you want to use a corridor or simply use the horizontal vertical alignment and use a parametric road model from InfoWorks. So a typical scenario would be that the road design is still evolving and you're going to bring in the alignment geometry. And later on, when the road design team is further along under design, you might switch it over to the custom corridor model. So in this example, let's start by saying, well, let's use the alignment and then we'll switch to a corridor later on. We've been working to make sure that it's fully compatible. I think in the August release, 95% plus of all corridor models from Civil 3D can be brought into InfoWorks. So now this is the new starting point. So the bridge design team now has this road geometry. So again, this is the horizontal vertical alignment and the parametric road from InfoWorks, which defines the lanes and shoulders, barriers, etc. And now the bridge design team can leverage InfoWorks, which is kind of in context modeling. What that means is you can add the bridges directly to your 3D model, place the foundations and abutments based on constraints that you see, etc. in context. So to place a bridge, you would go into the bridge tool and place it anywhere along. You can be very explicit with the exact stations or approximate and modify them later. It really doesn't matter, everything being parametric. The first thing you'll notice, of course, is when you place a bridge, that a bridge is created automatically. So you don't start from scratch and model every pile and foundation and pier. You start with a default bridge and you modify it. So in this case, I'm kind of mimicking what the Kicking Horse Bridge has. It has 5 piers. So the asset card on the right will expose a bunch of parameters, as will all the bridge components. So I'm going to change the number of piers from 11 to 5 and kind of move on. And then we can go in and change every parameter of this bridge. Click on a pier, change its column dimensions, or click on the foundation and change its pile design, layout, etc. What we also introduced a little while ago is the ability to right-click on the bridge and automatically create a fully formatted spreadsheet with all the bridge parameters. So especially on a complex bridge or a long bridge, you have access to all the parameters in an organized way. So in this case, a simple example is while we now have 5 piers, I might want to move them each to a very specific offset. So I want to have 70-meter initial spans, then 80-meter spans, followed by an end span of 54 meters. I could go in and click on each pier and modify them. But just to illustrate the spreadsheet concept, we're going to right-click on a bridge, and here you can see all the spreadsheets, worksheets. So every pier with the same kind of inventor model for its parametrics would be in the same worksheet. And here I'm just typing in a simple little formula to space the piers at exact stations that I want. And you could do that for really any parameter in the bridge. Save the spreadsheet and just open the spreadsheet or update the bridge from the spreadsheet in InfoWorks. Now you'll see the kind of the 70-meter spans, et cetera, that we added. From there on, you're going to parametrically model or modify the bridge. We don't want a 70-meter pre-stressed concrete girder spans. So let's go in and select a span and change the number of girders, set it to be curved and planned. In this case, unlike the actual kicking horse, which is 6 plate girders, 4 plate girders and substringers, I'm going to go with 2 composite box girders that are curved and planned. So I'm just going to pick from the library 2 composite girders. And every one of these objects will expose their own unique parameters. In this case, we can see when we select once more in the girder group, we could modify the top flange, bottom flange. We could also modify at any location along the span with these kind of blue slices you see. So you have quite a bit of control, but it's mostly, it's almost real time. So here in a few minutes, you're modifying the superstructure, applying it to the adjacent spans, and then moving on to, let's say, the pier. The 2-column bent of some 100 meters in height might not be appropriate. So I created a custom pier. All the parametrics leverage Inventor, Autodesk Solid Modeler. That really allows us to go quite far with the parametric models in a robust way. So here I selected a pier which is a bit more like the actual pier, a flared pier. I can change its own parameters. Again, every component might have its own unique parameters, and quickly apply it to the adjacent piers. And in a few minutes, the bridge design team might have a starting model. And now you might do some analysis, et cetera. When you're ready, and only when the bridge team is ready, would they want to publish this bridge? And why would you publish it? You might want to start doing all the technical documentation in Revit, adding rebar, et cetera. Or you might want to bring it back into Civil 3D to rework some of the grading or show the bridge in a long profile view. So at this stage, when the bridge design team is ready, they can publish the civil structure. And here you could publish it. You could work locally on your computer. You could publish it to your company network, your LAN, or you could publish it to Autodesk BIM 360, which is our cloud collaboration system. Any one of those approaches are available. So here I'm just going to publish it locally for this example. And once published, I can go in Civil 3D or in Revit and just open up this bridge. So again, now at the moment we have the road design team and bridge design team. Maybe we have a third team that's going to do all the detailed work in Revit, add the rebar, and do the construction sheets and schedules. So to model this bridge in Revit directly, it wouldn't be that simple. In this workflow, you just create your Revit model in your normal way, pick your template the way you want it, decide whether you're using Revit collaboration, work sharing, etc., and then go in and choose to import what we just published. So we've been working very closely with the Civil 3D and Revit teams as well. So we've introduced in Revit, in the latest version of Revit, a discipline called infrastructure. So this is beyond architecture and MEP. Now you have infrastructure, and we added a new set of categories for bridges. This is going to be evolve with rail and other infrastructure disciplines in the near future. But in the past, if you were in Revit, you would pick kind of the most suitable building category for your bridge. You might call a pier, a column, and a abutment, a wall, because you had to pick what was available in categories. Revit being category driven.
We have a question.
Yes.
Sorry, I didn't catch it quick enough, but the question is there allowance for AutoCAD Fusion 360, or is it only Inventor?
At the moment, it's Inventor. Fusion 360 doesn't quite have the architecture to do programmable parametrics remotely that Inventor has. Inventor has what we call Inventor Server. It's a headless version of Inventor. So we can, from the outside of Inventor, bring in Inventor components and change the parameters and have it all automated. Fusion 360 doesn't yet have that, but when and if it does, it'd be the intent to just open it up. I mean, InfoWorks sees a parametric content as here's geometry that has a list of parameters that are associated to it. We've looked at it. It's just not at the moment on the Fusion 360 side.
Okay, thanks.
So here, we'll get back to this a bit later. So you have proper categories, and we looked at IFC and Revit and came up with categories that make sense for civil structures, bridges to begin with. And when you're ready, just import what we published. This is we published that bridge from InfoWorks, and you just bring it in. And in a few minutes, you have the bridge. And now, of course, now you have three teams working side by side: the road team, the bridge team, and the technical documentation. In some companies, on some projects, it might be one team. In large-scale joint ventures, it might be different teams across different companies. So the workflow has to accommodate all those considerations. So here again, you might start doing rebar and sheets and schedules. In this example, I'm just putting in some spot elevations just to get the ball rolling in Revit, and then we'll continue with kind of the cross-product workflow. So here, again, these piers are almost 100 meters tall in this bridge. It's hard to get that sense from just the graphics, but they're very tall piers. And here we can also go, as I mentioned, directly in Civil 3D. So the road design team could bring in the published bridge directly into Civil 3D. So we can go in and import that bridge exactly in the same way, or in a similar way. So we're going in and bringing in the published bridge. And again, now, it's not just the fact that we bring geometry, but in both Revit and Civil 3D, all the parameters of the bridge, all the metadata is also there. In Civil 3D, they're shown as property sets, and you have access to all that information. Civil 3D now has layers and topology directly relevant for bridges. So when you click on the bridge component here, for instance, on this pier, I can go and look at the property set. So these are exact same parameters that are available for the designer in InfoWorks to manipulate. So all that information is there. In this example, we're going to use Civil 3D's long profile view, and we added the capability to project the bridges. This is something that on the Revit side, our clients have been asking for a while. We're still working on it to do developed elevations or curved and planned bridges that are projected correctly on an elevation view. Now, in the latest version of Civil 3D with InfoWorks, when you bring in the bridge, you can just say, well, project it to a Civil 3D. Now you have control on exactly which layers and styles, and all that is available here. I'm just using defaults, but it will create an elevation view with kind of a typical annotation there automatically. And now I'm going one step further. In the real world, the road design is always evolving, the bridge design is always evolving, and et cetera. So here, the road design team is already deciding to change maybe the vertical profile. This is one example. I'm making a large change, like a 15-meter change in elevation, just so we see it, but really any change has to be accommodated. And we can make the change, but we don't want the bridge to automatically update, because the bridge design team has to decide how they're going to accommodate this road design change. They might decide to change pier dimensions, etc. So here, the road design team is making changes, and they're going to essentially publish this Civil 3D drawing. Now, you can save the Civil 3D drawing and update it from InfoWorks, or you can be a bit more explicit and just say export an IMX, so you have a bit more control on this milestone. Either or. In the future, it's going to be a bit more formal with a published approach in Civil 3D as well. So here I just saved that drawing in InfoWorks. The bridge team might say, oh, well, we heard from the road guys that we have a new layout. So just go to the data sources and re-import. So in the past, you you could bring in alignments, not corridors, but you couldn't make changes to the alignment in Civil 3D. Well, you could, but it would create a new road in InfraWorks, and you would kind of orphan what you already had. So we've changed all of that. Whether it's a corridor or an alignment, you can at any time dynamically update it in InfraWorks. So here, when I re-import this updated road drawing, notice that in the background, the road will update and the bridge will dynamically update as well. So here we're saying, well, let's use that. So you can see the pier is now 80 some meters instead of 90 some meters. And again, at this stage, we don't want Revit to yet automatically update. We want the bridge team to decide, well, are they going to change dimensions or piers, files, run some analysis, etc. And when they're ready, they will publish, the bridge design team will publish a new version of the bridge. Now, in this example, what if the road design team at this stage said, from now on, we have a custom corridor with custom super elevation. So you can go in and say, well, let's switch from the component road to the corridor. So you can just switch at any time, and the bridge deck and bridge geometry will reflect the corridor if there are slight differences. Again, in the spirit of the three main teams collaborating and iterating at the same time. When the bridge design team is ready, they will publish a new version. So when you go and publish a new version, so here you can see publish, we update the existing version. And you can put notes, well, what did we do? What are the key changes? So our colleagues in the road and on the Revit side know exactly who did the changes, why the changes were made. And if we go to Civil 3D, for instance, you'll notice that it's going to tell you that there's changes pending from the bridge model. And when you click on it, and you can dismiss it initially or just accept it when you're ready, but when you accept it, you can see, well, who made the changes and when were these changes made? And when you accept these changes, notice in the background, this bridge is higher than the lowered road model, but when we accept the changes, the bridge in Civil 3D will be kind of compatible with the updated road design. Again, we didn't have to do any rework in Civil 3D here. The geometry and the relationship is all understood. It's just a question of when do you want these changes to take effect, so you have control on that. So the geometry is updated and the profiles are updated. In Revit, you get the same notification. So if you're in Revit at the moment, you'll get it, or the next time you open Revit, you'll get a notification such as this one. And when you accept the changes, the geometry in the Revit will update. And the derivatives, in this case, the annotations will be maintained, but just updated with updated numbers. The reason this works, of course, is Revit topology or the geometry has faces and so on. So rebar has a relationship to some faces. So as long as you're maintaining that same topology, just changing dimensions, making the pier flare wider or thicker, etc., Revit has a chance to keep all of those GUIDs intact and dimensioning and rebar intact. If you were to change the pier to column bent, then you would lose associated dimensioning that you put in there. But as you evolve the design towards detailed design, you'll typically start changing dimensions and not wholesale changes to the, you could, I mean, nothing prevents you even today from changing number of piers and so on. You might have to kind of do a bit more so annotation in Revit. All the properties are, again, in Revit, the quantities and so on. And now because we have categories and the infrastructure discipline, here we can see this new discipline that I was talking about. This is new as of the latest version of Revit. And the bridge categories, now we can go in and schedule really anything out of this bridge. So here I'm just scheduling piers, but you'll see later a lot more detail coming in the bridge models. All of this can be scheduled. So detailed tables of quantities, much more fine-grained, let's say, you could do in InfraWorks. So here you can kind of create. So again, this is kind of in that overview how road design, bridge design, and documentation can work together on the same project. The data kind of can be updated when desired. And so that's the introduction of that workflow. Now I'm going to jump into same workflow, slightly more complex project, just to kind of illustrate. Oops. No, that's not. Yeah, just 1 second. I think I have a different. Not too many videos here. All right, let's jump into this one here. Okay, so here is a more complex example of a corridor in Civil 3D, which is for a rail project. In this case, it might be a light rail, or so. In this case, we're starting with a detailed corridor from Civil 3D, and if we look at it, this corridor has areas for platforms and grading, etc. And this is going to be our new starting point for this rail design. So just to illustrate where this example is, I'm just going into Google so that we can see as well this actual project. This is just an internal case study, just to say, well, what if we had modeled this using this workflow? And this part of the video is just showing kind of that project in Google Earth. So you can see here the kind of the alignment, and you can see one of the bridges under construction over here. So we want to bring this corridor into InfraWorks now. So we could again model this whole corridor alignment directly in InfraWorks, but if you want the precision and you want to iterate towards detailed design, let's bring in the corridor. And when we bring in the corridor from Civil 3D, we'll use it directly in this case. Again, when you bring it in, you can bring in and configure all the sub-assemblies, exactly how they're going to look, and all the metadata of the sub-assemblies is going to be exposed in InfraWorks as well in the August release that is coming out. So here, when we bring it in, you can decide which aspects of the drawing you bring it in, and then when you configure it, you'll see here that you have many roads in this Civil 3D drawing. So I'm just going to turn off those I'm not interested in. Some of them are just minor roads, and you can see all the main geometry has a corridor attached to it, so we're just going to use that. We could again go in and configure all the sub-assembly visuals. I'm just going to use defaults here, but it could be quite detailed. And when you're ready, essentially this brings the whole Civil 3D corridor to life in InfraWorks. So it's as simple as just saying, open that IMAX or drawing and bring it in. So now we have the corridor directly in the InfraWorks model. And we'll just kind of do a fly through of this corridor. You can see some areas have retaining walls, and some of it has dual rail tracks and some platform areas. So that's the starting point for the bridge team. Now, to model the bridge in InfraWorks is far more effective than trying to do it with assemblies or sub-assemblies in Civil 3D. So we're kind of leveraging the strength of Civil 3D. The rail or road design team is providing this as a starting point, and then the bridge design team is going to augment it with the bridges and tunnels in here, and then furthermore leverage all the Revit detailing and documentation aspects. In large projects, it might be 3 different teams, as I said. In small projects, it might be the same. So you can see there's regions along the corridor that are meant for bridges, and so InfraWorks recognizes that from the corridor, and then it kind of goes back to grade, etc. So let's just kind of jump ahead here so here's an example. In this location, we want to place a bridge. I'm just going into different views so we see contours. And it works the same way when you start with a corridor. I'm going to place the civil structures bridge or tunnel, in this case a bridge. And when you hover over it, snaps to the beginning of that region of the corridor. So it's going to snap, okay. And then it's going to place the default bridge like we did before, and we'll change. So here I'm kind of trying to reflect from Google Earth the bridge had 3 piers. I'm just kind of making changes parametrically to mimic that, and we'll kind of change we'll move in context the pier location kind of to reflect the aerial imagery, so I could move and skew the pier. So this is kind of typical application. So I'm going to skew these piers to reflect kind of the orientation of the road that we're crossing, move it in place. As we do this, all the girders and bearings, et cetera, will dynamically update. And we can go and change the dimensions of this pier to reflect kind of what we're looking for. Again, each of the components that is in the library exposes its own parameters, and you can create your own very easily and add it to your own libraries. We'll see later that you can go beyond the components and add the bridges to your libraries. So here we have kind of this pre-stress concrete girder rail bridge. And what we're going to do now is, the other thing that we focused on is integrated analysis. So for the bridge design team, as you're laying out the bridge, you might say, well, let's do an analysis model. So we used to have the continuous beam model called line girder, where it would look at all the span geometry and create a continuous beam model using all the sectional properties of the girders and deck, and do live loading, surface influence lines, and so on, and carry out moment shear diagrams and do code design checks along the way. When you have skewed bridges or curved bridges, continuous beam model is not always sufficient. So we've been working on what we're calling refined analysis. So the first type of refined analysis is a grillage. So this is typically that next level of analysis. So the grillage will model the deck and all its girders with the proper skews and offsets. When you use a continuous beam model, you're using lateral distribution factors from code. So here, again, this is at a glance. You can quickly say, okay, let's create a full grillage model. We can look at it. And in the preview here, and it will create a whole report on every single section property that was computed, all the geometry, all the node locations, all of that is very transparent. So you can just go in and say, well, let's look at how it translated from the rich BIM model of the bridge to analytical simplification. So here you could go in and we'll show you all that information there. And you also have access to all that information if you want to bring it into some other software. So you can see the section properties, et cetera, and all the coordinates, et cetera. But you can also open it up in structural bridge design, which is included in the AEC collection. This is particularly well suited for girder bridges. It's been around the market for a long time. Autodesk acquired it 6 or 7 years ago. It's kind of the reference implementation. So when you have this grillage, you can just open it up directly in structural bridge design, modify it if you need to, but really quickly have access to all the analysis results on a more complex bridge like this, moment shear diagrams, et cetera. This is all available very quickly as you're laying out your bridge. That relationship between your choice of analysis model and the bridge is there. In this part of the example, I wanted to show a couple of other things here. The corridor has some grading, but what if you wanted to have a more complex grading, or you leverage this tool called line areas that allow you to kind of modify the grading directly in InfoWorks. This has been in preview for a while. We're adding it to the formally to the product. It's going to be called grading areas instead of land areas. So in this case, it's slightly contrived, but I want to change the grading around this abutment and replace the simple kind of civil 3D subassembly with walls with a much more complex MSC parametric model. So here, this grading tool allows us to modify the terrain either per vertex or the whole thing. So quite flexible. You can control the gradation and the steepness of that. But here I'm just creating space. I want to take this simple abutment that we have here with wing walls, and I created in Inventor MSC wall that has parametrically all the coping beam and railing. If you change the dimensions, all of it. But I also took those and created a custom. It's kind of a work in progress, but a MSC based abutment. I'm going to just go in and replace that in the same way that we placed piers in the first model. Everything can be swapped out to here. I'm going to place MSC wall, change its parameters. And also you can add content directly to the terrain, walls or construction equipment. We call it generic objects. They're basically three-dimensional Inventor objects that you can place anywhere. Here I'm just going to put the standalone MSC wall, and I just want to cap off that grading Again, I'm not saying it's super realistic, but just showing kind of the workflow here. So as a terrain-based object, you can control its location, its orientation, change its parameters. So again, you're interacting with the model directly. That's a key thing. And if you want custom content that's not in the library, you can definitely create your own. So here I'm just going to tuck it into the side of the grading and change some of the parameters so the slope reflects the grading slope. And you really, in a few minutes, you have something slightly more suitable, maybe, as an example. But the next part that we've been working on, what I'm showing next with the grillage analysis and what's coming up next with the cross frames is what's coming out in the August release. So in 3-4 weeks from now. Here you can see I forgot to toggle off the railing. Of course, we don't want railing right in front of the bearings and girders. But now we're going to focus on the next area of focus is level of detail of the bridge. So it used to be bearings were nominal. Now you can create your own inventor-based bearings, and it understands the relationship between the pier and the girders. If you say the girders are simply supported, it will update. If you change the geometry of the pier cap, the sole plates and masonry plates, etc., will adjust. Here I'm going to switch to another type of bearing altogether, and it will have its own parameters. So this has kind of a pedestal with anchorages and so on, anchor bolts. And I'm going to flex its parameters, maybe make it slightly larger. So again, this is kind of, we're increasing the level of detail of bridges, starting with bearings and then the steel framing, cross frames, and diaphragms. So you can quickly change it and then apply it to the other bearings at this pier or all piers. So in the same way that you can change one pier or all piers, or you can open it up in a spreadsheet and have even more control or en masse. I'm going to switch the pier to a different type of hammerhead as an example. So here you're just kind of in almost real time, you've tweaked the layout and you're going to assign it to the other piers. Now we're going to go and switch the superstructure from the concrete to steel girders. And now we're going to start applying the cross frames. So this is a new level of detail that's coming out next month. So the cross frames are relatively complex inventor objects that have real geometry, real eccentricities and gusset plates and so on. But as a designer, you just worry about what's their spacing, what's the relationship to the pier. If you move the pier, skew the pier, they adjust. Are the cross frames going to be staggered? Are they going to be skewed or not? You just work on the high level. Is it going to be V bracing, X bracing, Z bracing, single angles or double angles? Those are the kind of the metrics that you would kind of interact with. InfoWorks will place these very precisely based on the girder geometry. If you change a girder geometry, change the depth of the girders or flange dimensions, all of these will dynamically update. So there's a really tight relationship between the superstructure and these cross frames or steel diaphragms. They expose many parameters. You can have external stiffeners or not, etc. So you have quite a bit of control, and you can create your own with different layouts of diaphragms and cross frames. But again, a lot of effort was done to, you might configure a bay of cross frames, but you want to quickly assign it to the adjacent bays. This means that in early design, what you would normally in the past have left off for final design or detailed design is now available up front. That means quantities, and that means plans and elevations can have all this information. So instead of prorating your girder quantities, let's say 25% added to it for framing and cross frames and stiffeners, it can be very explicit now. But it goes beyond that. So here I'm modifying the cross frames over the pier with one which is a diaphragm type. So again, the idea is that you should be able to manipulate your parameters of the bridge and get to this level of detail in the August release. And when you're looking at this, you want to be able to, even in InfoWorks, get a sense of the quantities, so bare girders or cross frames. So that's available now. So here, let's go in, and in Inforworks, the quantities are kind of high level macro quantities. In Revit, with schedules, you can get into very fine grained tables of quantities. So here, I'm just going to go into the quantities and see how much concrete or steel, how much precast versus cast in place do I have for the structure, for the superstructure, for the substructure, or for selected element. So here, if I select this girder group, I can see I have 141 metric tons of steel. If I select one individual girder, it's 35. If I select the cross frame set, I have 10 metric tons, etc. So all that information is pulled out behind the scenes very precisely from the Inventor model. And again, you could open this whole thing up in a spreadsheet. And in this case, you'd have a worksheet with all the cross frames as an example. You might decide to go there and make some adjustments at that level. So there could be quite a few parameters that you could access at this in this approach. Now, the next thing it does is, let's go into another type of refined analysis, which is an offset girder. So it's kind of like a grillage, but the girders are centroidally offset from the deck. So it's just a bridge engineer choice. How do you want to discretize that? But again, when you go to structural bridge design, very quickly have access to this rich model that has the grillage and the girders that are centroidally offset. You can get moment and shear diagrams, etc., very quickly. Now, let's say we've configured this bridge and we've added, the bearings and so on. Now we could save this to a library of bridges. So maybe in your own company, you're going to create not only content, but save this bridge to, I don't know, typical BC MOT steel bridges and save it to your own library. And the next time, we're going to fly over to the other location, which has a longer bridge, 10 span or 12 span bridge, I can't remember. So again, we'll place the bridge here in that corridor region that exposes, that is available for us to place a bridge or tunnel. So I'm going to go in and place that bridge. But instead of going in and configuring and modifying and changing all these piers and girders, I'm going to just make sure that we have the right number of girders and the piers are where I want them. And then from there on, I'm just going to reuse that bridge template that we saved. So your starting point is much further ahead. So here I'm just going to the template. We just changed the number of piers to 10, and then I'm going to use a template. And it's going to update parametrically. Now we can, if we zoom in, you'll see that all these components have been swapped out to what that bridge template had. Again, it's not that it takes a lot of time to model these, but it's a question of being very organized with your content of parts, of bridges. And again, we could publish this bigger bridge like we did in the first video. There is the workflow to bring it into Civil 3D or Revit doesn't really care if it's big or small, simple or complex. And it's going to be geolocated precisely, compatible with the corridor, the coordinates between the three products will be consistent, etc. So here we just brought in this bridge in the original corridor model in Civil 3D. So when we zoom in, you can see, oh, now this bridge is right there. And because it's curved and planned, we might want to leverage the Civil 3D profile view again, so you can see here all the parameters. So we're going to go in and just assign this or add this to the profile view like we did before. And again, it's going to do all this annotation here. When we expand, you can see that it knows it has 10 piers, and each one of these we can configure what we want to show, etc. But we just basically apply this, and now we have all the components of the bridge shown in Civil 3D, including the abutments. And now, in the first video, we were looking at how the road design team changes the alignment. In this case, it's the bridge design team that's changing the bridge design. And so we move a pier and maybe change the length of piles on this one pier. Well, you can make many changes. It really doesn't matter. In this example, we're just showing, okay, let's reduce the length of the piles to 30 feet and then publish an update. So the changes can come from Civil 3D or from InfoWorks. So here we have a new version. Again, the notification that the bridge has changed. And when we update, we can see who made the changes, etc. And when we update the Civil 3D or the Revit, the geometry updates. In this case, the derived profile view also updates. You can see here that pier and the foundation is a bit different. The pile length is a bit different. The last part of this video goes into more of a road bridge. So let's have a quick look at that. So here we have, I just wanted to Google Street View and just try to mimic what they had, although I chose a different type of architectural pier that I had in my collection. Here we have composite box girders. So the internal, the crossbeams that we saw before, they can also be applied as internal, external bracing. All of that is understood. Here you can see a more elaborate pier model from Inventor. and we're going to do, in this case, a continuous line girder that we spoke of, which is just a simple continuous beam model, and use code-based distribution factors to get moment and shears. But what this has at the moment, it goes beyond just creating an analysis model. It actually carries out, creates the influence surfaces and the diagrams for moment and shear, and checks strength and stability all along the span. So, and it will tell you at a glance, where are you, but you can open up the analysis model like we did before, or view a full report of the calculations. Again, as you're iterating on your design, all of this is available in front of you. So it's a very detailed breakdown of strength and stability, the envelopes, all of that is available in the report. Again, this is the simpler continuous beam model. For these bridges, if you have heavy skews or curvature, you'll have to go typically on this steel bridge to find an element model, and those can take many days to create and calibrate. Now with this workflow, because the geometry, rich geometry of the BIM model InfoWorks is there, we can go to the FE model directly, right? Again, this is something for detailed design in the past. It's going to be available for early design, fully calibrated. So you can control some of the settings, the mesh densities, and so on, but it will create, it will look at all the girders, even if you have different number of girders, or even if they're not parallel, even if it's heavy skews, it will look at all the geometry and do all the meshing. Here you can see crack properties over the piers, etc., reflected in kind of different colors, and you can go directly into the analytical model here, directly look at how it's created, and go into the ASBD and look at analysis results. What's coming up next after that is we're going to tie in all the design checks that we see for the continuous beam model to these advanced grillage, offset girder, and FE models. So this allows you to, in early design, say, well, I wonder if it's more efficient to have 5 plate girders or 3 composite box girders. Is it more efficient to have variable depth girders or prismatic girders, et cetera, et cetera? What's the influence of heavy skews at the abutments? What penalty am I paying for that, et cetera? Because it's all integrated, you can experiment at that level. And when you're ready, again, just kind of publish this and go into Revit. And here you can see a much more detailed Revit model. All the information still came across. Again, it doesn't care about the level of the complexity. And you can go and put a section view and here kind of start annotating the elevation view of the pier, maybe put some dimensions, etc., on this pier directly in Revit. And as the bridge updates, in the past, if you're doing this in AutoCAD, if the bridge geometry changes, you'd have to do a lot of changes to your drawings. Here, if the road changes or the bridge changes, the derivatives can be updated. And if you want very detailed breakdown of quantities, maybe in this case, all the bearings across the whole bridge, you can just schedule that out, or maybe it's all the cross frames. Again, just go and do schedule that out, pick what you want to see, which are the parameters you want to see, and just it creates that long table for us. This is for the bearings, but you can, again, create your own for any other things. And again, you can interact. One last couple of things. When you're here, what if you wanted to say, well, I want to make this variable depth. So I can select any girder, and these yellow or orange slices give you the parameters at this specific location. You can add additional slices and maybe change this to a 10-foot depth. And as you do this, all the cross frame geometry will dynamically update. So it will reflect the new variable depth girders. You might want to have a kind of flat segment, so you're adding another slice there. So this is a spirit of really interacting with the bridge dynamically, and kind of assign those to the other girders. And then in a few minutes, you have another variation that is variable depth, and you might decide to rerun the grillage or the FE model. You might decide to update the Revit model, depending on where you are on your iteration or evolution of your concept. So that's kind of what I wanted to show today. I think we're at the bottom of the hour here, but hopefully it gives everyone on the call a better understanding of what's a connected workflow, how do road design, rail design, bridge design, and documentation work together, how you can iterate together, how you don't have to do all that rework, and how the increased level of detail is coming to the bridges, starting with the bearings and cross frames and next month. And there's other complexities coming, I think, in the coming releases. So that's it from my perspective, Laura.
Thanks, that's great, Ara. If anybody has any questions, they can type it in chat or unmute themselves.
Hi, yeah, this is Paul. I actually do have a couple questions. First of all, so this is mainly for bridge design, but let's say we have designed something like a rail system where you have a station located at like an elevated guideway situation. How easy is it to sort of integrate like building design coming in from Revit along with like a bridge design?
Let me pull up an example here. This is an example working with a client. So this is published at Autodesk University. It's a class we did. This is a good example of large-scale project that's actually under construction now that they use this workflow, where you can see the gaps in the alignment is where all the Revit stations come in, right? This is a joint venture with multiple contractors and many different design offices working on each Revit station. So in this case, the alignments were all in Civil 3D. All the parametric bridges were done in the InfoWorks, with obviously leveraging Inventor parametrics. It was very important that the alignment was kind of the datum for the project, and the geometry where these guideways interact with the buildings had to be exact, right? So in this case, when we published the bridge to Revit, they were also bringing in the Revit buildings and stations in the Revit model. You can see just at a glance the level of detail, which is in the InfoWorks model for the parametric guideway, but the gaps are while the buildings are. In this case, they also have a federated model in Navisworks, so for clash detection and so on. So everything also ended up there. So it's a combination. You can bring it into InfoWorks, but the layout and the precision layout that you have for these guideways and so on works very well with Revit. You're going to have, make sure the coordinate systems and shared coordinate systems and so on are compatible. In this case, the difference in spot elevation between Civil 3D, InfoWorks, and Revit was within, I think, I'm trying to remember, 1 millimeter or something. And they had a pretty high requirement for that precision. But yeah, does this give you a sense of it?
Yeah, I think so. My other question was actually involving GIS data. So like, so I noticed that there's the ArcGIS integration. You can export to file geodatabases. Is it possible to import data from ArcGIS file geodatabases, or is it mainly through shapefiles and the online portal?
Yeah, that's not my domain of expertise. I know there's a lot of effort with ArcGIS and the Esri portals. We could send us some questions to Laura and myself, and I can check my colleagues that work on that domain. I know I've been using kind of the vanilla model builder here, but our clients often have their own ArcGIS portals with much richer data that you can bring in. And you can also, I think, publish to your ArcGIS, but yeah, I'd have to confer with my colleagues who specialize in that.
Okay, thank you.
Any other questions from anyone else? I hope it makes sense. I hope you can all go out and give it a try. We're putting a lot of effort. There's still more coming. This is where we are today, and there's more refinements coming for tunnels. And just, at a glance, for those who are familiar with Vancouver, this is examples that we're putting together of a lot of the structures in Vancouver. This is the Golden Ears Bridge as an example in Google versus the parametric model in InfoWorks. So we're kind of going through and adding, basically testing it on complex civil structures, complex tunnels. Here you can see kind of the parametric tunnels that are coming a bit later, that bored tunnels with very detailed liner segments, LRT guideways that we have in Vancouver. So lots of refinements. A lot of this you can do today. There's just improvements, simplifications coming, so it's easier to do. We're adding more content. So out of the box, you have richer content. So yeah, that's kind of what I wanted to show today.
That's great. Well, I think if nobody has any more questions, somebody's typing, so. Okay, no, I guess no more questions.
One more comment. We are working, and this has been BC after all with building smart. We are working closely with a number of IFC initiatives. So 4x3, 5.0. There's a lot of momentum finally going in that direction. So there's another aspect that we want to be at the forefront, to have a kind of open ecosystem.
That's awesome. Fantastic. Well, thanks so much. And we will post this recording. And if anybody shoots me a question for you, I will shoot it to you, Ara. So thank you so much.
Excellent. Thanks, everyone.
Thanks, everybody, for coming. Bye-bye.
Bye-bye.